Good day, metric students. It's been a minute since time immemorial, and today I want us to discuss at least a real case of death, and that is trigonometry, where you need to carry the weight of responsibility with no apparent end, more especially with regards to trig identities. Let's check what we're having here. 5.1. Simplify the following without the use of a calculator. Let's do it together. I'm going to write a 5.1 and then 5.1.1. They want us to simplify the tangent of 480 degrees multiplied by sine of 300 degrees. Let's copy that down. We've got our division just right here. That is a tangent of 480 degrees multiplied by a sine of 300 degrees multiplied by a cos of 14 degrees multiplied by a sine of a negative 135 degrees. I'm just going to enlarge my division here. So you can check there, we have tan of 480 degrees, sine 300, cos 14, and sine of negative 135 degrees. Well, we also have got a sine of 104 degrees multiplied by a cos of 225 degrees. Sine of 104 multiplied by cos of 225 degrees. We want to simplify this one. First thing first, I'm going to make sure that I rewrite my angles in a manner that I'm going to be able to do the reduction. In this case, I have 480 degrees, which is basically something in the second quadrant, and that is your revolutionary angle in the fourth quadrant. You also have a very small angle there, that is your acute angle, and that is fundamental identity, where you're going to take the negative outside and you remain with the obtuse angle there, that is 135 degrees. And you also have obtuse again, and you also have a reflex angle. So I'm going to be playing with that nicely. Let's check how we do that. So that is going to be, I'm now going to take that angle. Remember, that is now in the second quadrant. It's basically obtuse, which is going to give you a tan of 120 degrees. How do you do that? You say 480 minus 360 degrees multiplied by sine of 300 is still in the domain of 0 to 360, so you don't need to really do anything with that. Multiply by cos of 14 degrees then, and then multiply by this one is basically the fundamental identities, where you're going to get a negative sine of 135 degrees. All right, and then now you still have your sine of 104 degrees multiplied by a cos of 225 degrees. Now that you have got your angles, all of them in between 0 to 360 degrees, therefore we can apply reduction. And we're going to say to ourselves, this is equals to the tangent, that is going to be 180 degrees minus 60 degrees, just like that. You multiply this by sine of 360 degrees minus 60 degrees, then multiply by this one. You can keep it. You don't really use reduction on angles that less than 90 degrees. I hope that you know, so you can keep that. And then that is going to be cos of 14 degrees multiplied by, be careful there, that is minus sine of 180 degrees minus 45 degrees. Then you close it nicely, and then now you are going to have this angle, especially in the second quadrant, it's obtuse, so you're going to have possibly sine of 90 degrees plus 14 degrees there, and then that is in the second quadrant, it's going to give you back 104 multiplied by cos of that is a reflex angle, right? It's going to give you 180 degrees plus 45 degrees, just like that. And then you now need to simplify this. Let's do it together. that is in the second quadrant. So you're going to have a negative tangent of 60 degrees multiplied by, still in the fourth quadrant, so you're going to have a negative of sine of 60 degrees multiplied by, you can keep that cos of 14 degrees, and then this is going to be in the second quadrant. So but this negative, it must be maintained. This become negative sine of 45 degrees, and then you close that. Let's check what you have now. You have that is in the second quadrant where sine is positive, so you're going to have a cos of 14 degrees, multiply by, this is in the third quadrant where cos is negative, so you are definitely going to get negative cos of that special angle, which is 45 degrees there. And what you can do now is to simplify. Cos 14 is going to cancel with that, and this has the same value with that, so it's going to cancel with that, and then you basically have a negative tangent of 60 degrees multiplied by a negative sine of 60 degrees. And now you can really apply your special angle identities. That is going to be negative by negative is positive, so we are going to get the square root of 3 for tan 60, and then this one is going to be the square root of 3 over 2. Well, the square root is going to undo each other, and then you're going to be left with 3 over 2 as the possible value for the first one. That's how you really simplify that. And then now let's check the second one. We have to simplify cos of 90 degrees minus 2x multiplied by the tangent of 180 degrees plus x plus sine squared 360 minus x. So let's do it together as well and see how far we can go with that. So that is 5.1.2. We have a cos of 90 degrees minus 2x multiplied by a tangent of 180 degrees. This is 180 plus x plus sine squared of this is 360 degrees minus x. So what we're going to do now is to apply the basic laws, which are your identities. This is now in the second quadrant where you're going to apply co-functions. All right, so this become a sine of 2x multiplied by, this is now a reflex angle where you're going to have a tangent of x there, plus this, you can say to yourself nicely that this is sine of 360 degrees minus x. You close that and then you put a square there. All right, and then now this is going to give you the identity there. You must change that to be 2 sine x times a cos of x, and you must also change that to be sine x over cos x, just like that. And then you are going to have a positive, this inside part, it's negative sine x, and then you square that negative sine x, is going to give us sine squared of x, just like that. And then now you try to simplify this. This is going to, this cos x and this cos x are going to undo each other, and then you are going to be left with 2 sine sine times sine is sine squared of x plus a sine squared of x, and that as a result is going to give you 3 sine squared of x. These are like term, so they amount to 3 sine x squared, because this is twice and this is just single. When you add them, they are going to give you 3 sine squared of x. This is how you are going to simplify that without the use of a calculator. Let's check what are we having here in 5.2. Shown below are the three trigonometric identities which form a pattern. So you have a sine of theta minus cos theta over 1 minus tangent of theta is equal to negative cos of theta. And then the second one is that you have sine squared of theta minus cos squared of theta over 1 minus the tangent squared of theta is equal to minus cos squared of theta. The third one is that you have a sine cube of theta minus cos cube of theta over 1 minus tangent of cube of theta is equal to the minus cos of the cos cube of theta. So what we notice here is that the negative really keeps popping. And one more other thing is that this value of 1 here keeps increasing by 1. In this case, you're going to have 1 and the second power here. And here, the very same power must be maintained in your tangent, also just right here. And then now you're going to have this power here. And by the way, from this one, the power must also be here, just like you have 1 in there. And then now you have cubed in this point and also at that point as well. And this should also be here. That means now if I'm to have a sine of 10 of theta minus cos of 10 of theta, this is going to be 1 minus a tangent of 10 of theta, which is going to give me that negative is there as a pattern, cos of to the power 10. This 10 must be maintained in there. That is the meaning of this particular pattern in there. So let's check how we're going to answer the questions related to this one. They're saying use the pattern to write down the value of sine 2022 minus cos of 2022 of theta there over 1 minus, they still maintain that tangent of 2022. So it means that it's going to have a value of minus cos to the power 2022 of theta. That is the meaning of that. So let's do that together. So that is sine of that. Okay. So let's do it. 5.2, 5.2.1. We have a sine of 2022 of theta minus a cos of 2022 of theta. This is divided by a 1 minus the tangent of 2022 of theta. That has a value of a negative cos of 2022 of theta, just like that. All right, that is the pattern that we are observing there. And then now the next question, let's check what are they asking us to do there. The next question, they are saying that for which values of theta are the identities in the pattern undefined, where theta should only be or the angle should only be in between 0 to 180 degrees inclusive of 0. Mark that. So I'm going to copy this. They are saying for which values of theta are the identities in the pattern invalid or undefined or not true. So let me copy them down for you. So we have the first one, that is that is a sine of theta minus a cos of theta divided by 1 minus a tangent of theta. That is equal to negative cos of theta. And then the second one is that we're going to have the same thing, hey? Sine square of theta minus a cos square of theta divided by 1 minus the tangent squared of theta. That is equals to negative cos square of theta. Now, the last part of it, very interesting. That is a cos cubed of theta. This should be minus. This should be sine, eh? So this should be sine of cubed of theta minus a cos cubed of theta divided by 1 minus a tangent of cubed of theta there. that is equals to negative cos cubed of theta. They are saying for which values of theta in the pattern. This is your pattern as the identity there, and undefined. Notice that every identity is going to be undefined if and only if your denominator is equals to 0. So to answer this in a sense of justice, I'm going to equate my denominators, all of them, to be 0. Think about it. If I do that, I'm going to start with the first one to say that 1 minus a tangent of theta must be 0. And the other one, which is 1 minus a tangent square of theta, must also be 0. Lastly, you have 1 minus a tangent of cubed of theta must also be 0. Now, if you try to solve one of these, for the first one, you're going to get tangent of theta is equals to 1. And then here, you're going to have a tan square of theta is equals to 1. And then this side is going to be tangent cubed of theta is equals to 1 as well. Now, this one already it is solved. This one, if you solve it, you are going to get a tangent of theta is equals to plus or minus 1. And then this one, you are going to get tangent of theta is equals to 1. So what we are seeing is that this tan theta is also repeating here, and it also repeats here for plus or minus. That means now I'm going to take this one because that is the one that is appearing, in both. That is the one that is giving both answers from the three of them. So let me delete this and say that this is going to be undefined if and only if 1 minus a tan square of theta is equal to 0. And then I must solve a theta here. That theta here must be, think about it, you were told that theta must be in between 0 degrees to 180 degrees. That's where we must play around. So let's do it nicely now. We're going to get a tan square of theta, which is equals to 1. We try to solve our tan theta. This becomes plus 1, or tangent of theta is equals to negative 1. So if I solve for theta here, this is going to give me two possible solutions, and that is theta is going to be 45 degrees. It's going to be plus 45. I can really do it with the general solutions because I'm given that part. So let me write 180 degrees k, where k is an element of integers. I can say or theta is going to be, remember that's tangent is positive in the first quadrant and the third quadrant. So this should possibly be, if you add 45 from 180, so 180 plus 45, that is going to give me 225, which is outside the bounds, but it's good that we write it. So this is really going to be 180 degrees k, where k is an element of integers. That's the first part. We get these two guys here. Now let's check the other one. The other one, we are going to say where is the tangent negative. So it's negative in the second quadrant and the fourth quadrant. So that means theta is going to be 135 degrees for the second quadrant part. Say 180 minus the reference angle of 45, and then plus 180 degrees where k is an element of integers. Think about that one. That should really be easy. Where k is an element of integers, and then you write or is negative in the fourth quadrant. So that is theta is going to be 360 minus that 45 degrees is going to give you 315 degrees. All right, for the third quadrant, for the fourth quadrant, plus 180 degrees where k is an element of integers. So now they want the solutions to be in here. So you will say to yourself that since k is an element of integer, you're going to have theta is equals to 45 degrees. It belongs to this interval. You are cool with that. So you're going to have 45 degrees. And then the other one, this one, it is outside, so you can't take that. But this, it is within that bound. So I can take 135 degrees. I need to be very careful now that since notice that if you take k as 0, if you plug it here, it's going to give you 45, and if you plug it here, it's going to give you 225, and if you take it here, it's going to give you 135. That is where we agree with that. And now if you take a 0 and put it here, it's going to give you 315, which is outside this bound. Therefore, now I need to check the other ones. If I take negative 1, for this one, it's not going to be true. Let me take negative 1 and put it here. I hope you know what I'm doing. You take negative 1 and put it in a position of k. That is going to be 225 minus 180. That is 45. So already I have it. Now let me come this. If I take negative 1 and put it here, hey, if I take negative 1 and put it here, it's going to be a negative answer. So let's leave that. Now let's come here and take negative 1. If I take negative 1, this is going to be 315 minus 180. That is 135. That is 135. So already I have 135. So I need to get the other one. Where am I going to get the other one? If I take 1, already it's going to be out. And then let's check now. If I take negative 2, it's going to be a negative answer as well. And then if I take negative 1 here, that is going to be 135. That is out already. I'm trying to check if I have more values on that one. Unfortunately, I'm not seeing any other values. And I can't take 2, because if I take 2, that is going to be a big value outside that prescribed bounds. So I'm thinking if I take 1, already 1 is outside of all of them. Yeah, even this one can do. Even, yeah, that's the solutions. That's the solutions. We are getting just 2 of them. 1, negative 2. It's going to be negative answer. So 180. Let me check something. 315 minus 180. That is 135. Yeah, that is how you really go about that one. So there are 2 possible answers there on that. Now we look at the next question. That was 5 marks. Now they say write down the nth term of the above pattern in terms of the given identities. The nth term. So the nth term, they want the general term, the nth term of that. So this is going to, when this number is n here, that means this is going to be n, and n just right in there. So I'm just going to put n in that position. That is going to give us the nth term of the problem. Let me copy that and write. This was 5.22. Now we are going to 5.2.3. We're just going to write the nth term of this, and that is going to, this is going to be n, hey? That is the nth term there. Put your n there. Let me delete this 2 here. And then we put your n there. Just like that. And the theta, I may really need to put it here. And also this one here. Just trying to be neat. Cool. Yeah, that's how you really go about that. It's a very easy stuff. I hope you guys can see that. So that is the nth term of the given pattern. Now, what is happening with the last one? It's a 5.2.4. What are they saying? Show that that nth term is that one. So now we have to prove that nth term. Okay. So let's do it together. Okay, we have to prove it that we have a sine of n there, and then a minus cos of n of theta divided by 1 minus tangent of n of theta, that is equals to negative cos to the power n there of theta. So let's prove this from the left hand side. So that is our left hand side. I may need to copy that so that I work it out. Let's see if we're going to get a negative cos of theta. So this, in a sense of justice, we are going to have a sine of n of theta minus cos raised to the nth power there of theta. You change that tangent to be sine of n of theta over cos of n of theta, just like that. And then you take your LCD in your denominator. So you still have sine of n of theta minus cos of n of theta there. And then this one, that's where you need to take the LCD of that. So that is going to be cos raised to the nth power there. Remember here it's over 1, so into that times 1, that is going to be cos to the n of theta minus this into that is going to be 1 times that. That is a negative sine of n of theta, just like that in there. And then now what we're going to do is we're going to simplify this fraction. So we have a sine of n of theta minus cos of n of theta there. Now, this is divided by that quantity. So we're now going to change that to be the inverse of that by the multiplication. So this division changes to a multiplication. And the moment we do that, this becomes our numerator. This becomes our numerator. We call this the inverse. So we're going to have a cos to the power n of theta divided by cos to the power n then, minus sine to the power n of theta. And then what we are noticing here is that these guys, they can't cancel unless if we factor out the negative of this one, all right? Or even that one of the two. In this case, I'm going to take out the negative of this one, which is going to be, in fact, this negative, let me put it with its own color to say that we have a cos to the power n of theta minus sine to the power n of theta. And then you still have this arrangement here. Let's just duplicate them and you have them in that case. So now you can really do your maths the way you want, which is to say that this cancel with that, and this leaves you with this negative here and the cos of nth power of theta, which is the right hand side. This is how you'd go about this question. It's not really a difficult thing to do. It's not really a difficult thing to do. In a sense of justice, that's how you really, if you have any question, you are more than welcome to comment, and we're going to take it from there. Otherwise, thank you so much for sticking and staying with me throughout. See you next time.